Hello again. So we are going to continue with the sine and cosine functions. We're going to deal with horizontal and vertical shift for this section. So we have dealt with the amplitude, the leading coefficient. We have also dealt with the b value, which actually helps you to get the period of the function. Okay, so we dealt with b as well. Now notice that both of them are the same. I used a sine and cosine interchangeably so that you can see that they are exactly the same. All right, in terms of the function transformation, that does not change. All right, now we're going to deal with the plus or minus c and plus or minus t. So I want you to consider the order of transformation when you deal with the trigonometric functions. It's exactly like the polynomial functions. So the next piece that we got to deal with is the horizontal shift and then vertical shift. Let's consider cosine function, and then we're going to compare these two. Now we know that if we have anything added or subtracted to the x value in the bracket, that represents the horizontal shift, left or right. So in this case, we know this would be a horizontal shift to the right. So, and by how much? So this horizontal shift, this is pi over 2 to the right. Okay, simple as that. Now let's go to Desmos and see what's happening there. All right, so let's look at the original function right now, y equal to cos x. Okay, so this is the original function, and we can look at one period between 0 and 2 pi. Very nice. So we can actually see that. That's great. And then when we do the cos of x minus pi over 2, what it means is that this graph will be shifted towards to the right by pi over 2 interval or unit. All right, so that means this coordinate right there, where is 0, 1, becomes pi over 2, 1. And every other point on this original cosine function will shift accordingly by pi over 2 to the right. So here is the graph of cos of x minus pi over 2, and notice that, yeah, so as we talked about this, everything has been moved, so that coordinate is moved now. They went from 0, 1 to pi over 2, and then so forth and so on, because every single one of them, so this coordinate right there in the original graph now moved pi over 2 over, so it's right here now. Okay, so the blue graph is now the transformed graph of the cosine, and if you look closely, this is actually the sine function. Okay, so if I actually go ahead in here and punch in sine function, you will get the exact same thing, and that's how they're related. Okay, so that's what that is. All right. Okay, so here is the notes for that using the Desmos. I just pasted in here, and you can see the shift is positive shift of pi over 2, and the graph, the blue graph, is the transform graph. Okay, just simple as that. Notice that nothing else has changed. The period of the function is still the same. You know, you go from pi over 2 to 5 pi over 2. The period between these two, right here and right there, this period is still 2 pi, because we haven't changed the value, the coefficient of x. Okay, so that's still 1. That means 2 pi over 1, that would be 2 pi. So that is the same. Amplitude is the same. Amplitude is 1. We haven't changed any of that, and that is basically it. Okay, now let's go ahead and look at the vertical shift. So there is no surprise to you to see that if you're adding a value, a constant, to the original function, so this is the plus 1 in comparison to 0, or vertical shift by plus 1 or up by 1 unit. Okay, so that's basically it, the exact same thing as the polynomial function. So let's go ahead to the graph, to the Desmos, and see what is happening. So here's the original graph of y equal to cos x, and guess what happens when we add 1? Well, what will happen is that every single coordinate on the original cos function, the y value of that will go up by 1 everything will go up by 1. Now everything goes up by 1, and then what I need you to notice is the midline now will be changed. So instead of being x-axis here, the midline of the function, remember the cosine and sine waves or sinusoidal functions, they have a midline that actually splits the graph into two, and that's a very crucial part because you can get the amplitude out of that. So let's look at it. Here it is. The whole graph has been moved up. Okay, so this coordinate right there, which was -1 for the y value, went up by 1, and this coordinate here, 1, it was for y, goes up to 2, and so forth and so on. And notice now that the midline here is not x equals to 0, sorry, y equal to 0, which is the x-axis, but has gone up to y equals to 1. Everything else is the same, the amplitude the same, everything is the same. So let's now put it in the notes. So here it is, the original graph we have, the red one. So notice that this y value that has been +1, the one that is added to the function, moves the graph by 1 unit. Period is the same again between you have a period between 0 right here and 1, sorry, 2 pi. So that's the same. The amplitude is the same, but then the crucial part that I want you to pay attention to is that the midline now, this is the midline. Now, why is it useful to have a midline? Because when you have to graph this from scratch, you need to know where the midline is so that you can get the proper altitude. So you have to know where the midline is. It's very important. And that midline usually is represented by this vertical shift. Okay, that's what that is. And then from this point on, you can go ahead and look at the other components of the function, and then come up with the period, with the amplitude, and everything else. All right, so nothing else has changed, and simple as that. Here it is. Now notice one more thing, that I used only cosine function for the purpose of demonstration of this transformation, but the same thing, exactly same thing for the sine function. Very exact the same thing. All right. So just to make sure that we are all on the same page, what happens if we want to look at cos of x minus 2 in reference to cos of x? What do you think is going to happen? Well, the red graph, which is the cosine function right here, will drop down 2 units. Okay, so let's go to Desmos, and you can see what's happening. Here it is. So that's the original graph. All right, the cos of x. If I drop that, put a -2 in front or at the end, everything drops down by 2 units. Every y coordinates on the of the original graph drops down by 2 units, and that's basically it. Now, what is your midline now? The midline is y equals -2. So this constant term or constant value, that's the equation of your midline, which is y equals to whatever the value of the y is. In this case, will be y equal to -2. All right, simple as that. Nothing else has changed. We just moved the graph up or down, and then of course we went back to the left and right with the original. Okay.